Welcome again, grade 12s. This is the last video or the last example that I'm going to do based on electrical circuits. So the opening statement says, in the diagram, the battery has EMF of 10 volts and unknown internal resistance. Voltmeter V1 is connected across the battery and voltmeter 2 is connected across the open switch S. So you have voltmeter 1 that is connected across this battery, and then voltmeter 2 which is connected across switch S, and then the EMF is 10 volts, and then the internal resistor of the battery is unknown. Okay, so it means that now we have to understand the concept of internal resistance. So the internal resistor, it is the resistor of the battery. So it means that the battery also has a small amount of resistance when it provides or it supplies the external circuit with energy. Okay, so let's see what our question say. So question 1 says, what is the reading on voltmeter 1? Okay, so I'm going to answer these questions in this paper, since they are some sort of short questions, and then the other ones that require calculations, I'm going to do them in the board. So what is the reading on voltmeter 1? So voltmeter 1, it is connected across the battery, and then the switch is still open. So when the switch is open, obviously there won't be any current flowing in our circuit because of the switch is still open. Okay, and then as you can see, this voltmeter is connected across our battery. So since while it is connected across the battery, it is going to measure the total energy that the battery can supply, which is the EMF. So it means that the reading on this voltmeter 1 is going to be 10 volts. Okay, and then the next question says, what is the reading on voltmeter 2? So we have voltmeter 2 that's connected at 2 terminals of our switch. Okay, so it means that this voltmeter 2, it is going to measure the total EMF of our circuit when the switch is open. Okay, so because of it is connected at the 2 ends of our switch, it is also going to measure 10 volts because of now the current is not flowing yet in our circuit. That's why it is going to measure the maximum EMF. Okay, so it's also going to be 10 volts. Okay, so now the opening statement of the following question says, when switch S is closed. So now we are closing this switch. So when switch S is closed, the reading on voltmeter 1 drops to 7.5 volts. Okay, so the readings on voltmeter 1 drops to 7.5 volts. So when we close the switch, we see this EMF of voltmeter 1 dropping to 7.5 volts. So we wonder what happened to 2.5. Okay, we wonder where the 2.5 went. The 2.5, obviously, it is what we call the lost volts. Okay, that's what we call the lost volts. It means that it is used inside the battery. So before the battery can be able to provide energy, it must use some of its energy to have the energy to deliver the energy to the external circuit. So it means that that energy 2.5 was used by this internal resistor in the battery. Okay, so going back to the question, what is the reading on voltmeter 2 now? So when we close the switch, we want to know what is the reading on voltmeter 2. So when we close the switch, it means that now the resistance in the circuit is no longer greater as it was before we closed the switch, okay, because of now the current is starting to flow. And then since now we don't have any resistor here, this voltmeter is going to measure nothing because of the resistor of the wires in the grade 12 level is neglected, okay. We avoid the resistor or the resistance of the wires. So when the current is going to flow here, because of there's no resistor, the voltmeter is going to measure 0 volts, okay. So it means that the reading here is going to be 0. So we're going to have 0, okay. So question 4, so this one I'm going to do it here in the board. So question 4. So question 4 says calculate the reading on the ammeter, okay. So you want to know what is the reading of the ammeter when switch is closed. And then remember, when the switch is closed, this EMF has dropped to 7.5, okay. So you want to know what is the reading of the ammeter. So it means that now we are calculating the current in the external circuit. So before we can know the current that's going to flow in the external circuit, we must firstly find the total resistance of the circuit. But then the total resistance that we're going to calculate, it is what we call the external resistance, okay, which means we're going to calculate this one. This one is the external resistance now, because of now the battery is supplying the energy and the current is flowing towards the external circuit. That's why you have to find the total external resistance. After we have found this total external resistance, we'll be able to find the current, the external current, okay. So therefore, when you see this black color, we know that the total resistance is equal to the resistor that is in series plus the resistor that is in parallel, okay. So which is the same as the resistor that is in series is the 1 ohm resistor, okay. It is the 1 ohm resistor. It's the only one that is in a series in our question, okay. So we're going to have 1 plus Rp. So this one we have to calculate it based on its formula, okay. So we know that Rp, I mean 1 over Rp is the same as 1 over resistor 1 plus 1 over resistor 2. So 1 over Rp same as 1 over resistor 1, let's say it's 6 ohms plus 1 over this one, 3. So 1 over Rp is the same as 1 over 6 plus 1 over 3. So they give me half, okay. So now we want Rp, we're just going to introduce the reciprocal. So therefore Rp is the same as 2 ohms, okay. So now we have gotten the equivalence of this one, okay. So we're just going to continue from this formula. So RT is the same as the one that is in series, 1. So we have 1 plus Rp is 2. So it means that RT is the same as 3 ohms, okay. So now we have found the total resistance of the circuit. So it means that now we can be able to find the total current of the circuit, since we've been given the external voltage, okay, or sometimes it is called the V load. Okay, here they're giving us this V load. This is our V load. Okay, so now we just have to calculate the total current, because of the question said calculate the reading on the ammeter. We wanted to calculate the reading here, so it means that now current according to Ohm's law is V over R, so it's the same as the external voltage, which is 7.5 divided by the total resistance that we have calculated, which is 3, the same as 7.5 divided by 3, so we get 2.5 amperes. So it means that the current that is going to flow in our circuit is going to be 2.5 amperes. So this is the current that is going to flow in our circuit. Okay, so it means that the ammeter is going to measure this 2.5 amperes in our circuit. Okay, so number 5, the last question, says calculate the internal resistance of the battery. We have to calculate the internal resistance of the battery. So it means that now we have to calculate this R. We want to know what is the internal resistance of the battery. Okay, so in order for us to be able to calculate the internal resistance of the battery, we must use the formula that we have learned. Okay, must use the formula that we have learned here in grade 12, which states that the EMF is the same as V load plus the V internal. Okay, sometimes this V load they write it as external voltage. Okay, so external voltage and V load is the same thing. Okay, because of now we're talking about the external resistance, the resistance that are outside of the battery. Okay, so when I simplify it, I'm going to have EMF the same as I times R external, okay, plus this part the same as I times internal resistor. Okay, this one is the same as the current multiplied by internal resistor. Okay, so now we want to know, okay, let me just put small r here to show that it is the internal resistor. Now we know what is the EMF in our question. The EMF is 10 volts. We're just going to substitute. We're going to have 10 volts is the same as the current we have calculated. It is 2.5 amperes. We have 2.5 amperes multiplied by the external resistance. Okay, so external resistance, it is the total resistance that is outside of the battery. We have calculated it. Okay, we found it to be 1 plus 2, which is 3. So multiply by 3. I'm sorry for that. Multiply by 3. Multiplication plus the current again, which is 2.5, So the internal resistor, we don't know it, that's what we want, so we'll multiply by R. Okay, so now we're just going to do mathematics. So I'm going to have 10 is equals to 2,5 multiplied by 3, which is 7,5 plus 2,5 R. Okay, let me create a space. So I'm going to take 7.5 to the other side, and then it's going to be 10 minus 7,5. It's going to be 10 minus 7.5 because I've just taken this one to this side. Okay, then I get 2,5. So 2,5 is the same as 2,5R. So when I divide both sides by 2,5, this one is going to cancel this one. Then I get that my internal resistor is equals to 1 ohm. Okay, so we can see that the battery has a very small resistance. As you can see here, it is 1 ohm. It's very small because of it is inside the battery. So it means that this internal resistor or internal resistance is the one that causes loss of volts. That's why when the switch is closed, we see the reading on V1 drops from 10 to 7.5. Why? Because of this resistor, it has used some energy of our battery before the energy can travel throughout our circuit. Okay, I hope you guys have understood what I've done there. In electricity, it is very important for you to practice every day. It is the same as mathematics because we have many calculations. So when you know the theory behind the calculations and then you practice regularly, you'll be able to solve any circuit that they're going to give you in the examination or in class tests. Okay, yeah, so that's what I can say so far. Okay, thank you guys for watching this video. I'm going to see you guys in other videos where I will be shooting about other topics. So yeah, if you have questions, you can just text me or comment in the comment section. Yeah, see you guys next time. Bye bye. Don't forget to like and subscribe, and also don't forget to share with your friends so that you guys can do well in your physics exam. Okay, bye.